Welcome to the INSEVIS video tutorials. My name is Fabian, and today's topic is the connection of our decentralized periphery with the CAN bus. All PLCs from INSEVIS are supplied with a CANopen compliant master out of the box. The INSEVIS CAN interface enables a comfortable CAN-conform configuration here in the config stage. The whole thing works for INSEVIS' own decentralized peripherals, as well as for decentralized peripherals from other suppliers, which can be easily integrated via an EDS file. We have already documented the complete CANopen configuration in a video. The video is linked below in the video description. The whole configuration can actually be done without any previous CAN knowledge. There are, of course, a few small things to keep in mind that this video is all about. The first thing to consider is the connection of the wires. It is essential to follow the wiring diagram. With decentralized peripherals, pins 2 and 3 are used for CAN. With the CPU-T, pins 9 and 10 for CAN high and low. And with the old CPU-V, it's pins 5 and 6. The next step is to set the baud rate according to the line length. Of course, other interferences must also be taken into account, which could make it necessary to lower the baud rate, or use shielded cables to counter the interferences if the worst comes to the worst. The next thing to do is to make sure that the node ID is set correctly, both on the unit and in config stage. The whole thing is done in hexadecimal, and the lower cog is the lower nibble. Now everything has been set, but the run LED is only flashing. There is no function. How can that be? Well, maybe the mistake was made that a decimal number was used by mistake instead of a hexadecimal number. Or you have used a node ID that is too high. Please use a maximum of 31 hex for the node ID. An interesting story is also that node failure can occur after a power cycle, i.e. when the machine has been restarted or similar. How can that be? If somebody played with the node ID before the power cycle, nothing happens at first. But when the node is restarted, it reads itself again and finds out that it doesn't fit with the selected number, so it is not configured properly and stop working. Some of our peripheral modules, like the PMDI08Z and the PMMI084, need special function blocks if they are operated on a decentralized peripheral. These are available for download on the INSEVIS homepage. Of course, they are also linked here in the video description. The issue of bus termination. We have already had cases where the customers simply switched on the terminator resistor at each participant of the bus. Of course, the whole thing didn't work then. The bus termination is done at each of the two ends of the bus system. With very short bus lines, it may also be possible to terminate at only one device. More often we are asked, the CAN ground, does it have to be connected? Well, the CAN ground is already connected to the normal ground of the 24 volts. That means all the participants that are on the same 24 volts, or where potential equalization exists, you don't need to connect this separate CAN ground. It is only necessary if the system parts are far apart, where, for example, there is no longer potential equalization, or also in outdoor systems, where it is then additional recommended to use a shielded cable in order to have a certain lightning protection. What does it mean when my yellow LED flashes? Well, that's the communication monitoring. We have a guarding time of 350 milliseconds by default. If within this time the response does not come, the LED starts flashing yellow. If the node does not respond to the guard within 3 times, the node will be switched off and the outputs are denegated. To prevent the PLC from going into run-stop mode in the event of errors in decentralized modules, it is recommended to use OBIS 82 and 86. OB82 is for diagnostic alarms. If, for example, the diagnostic capable modules send error messages, that these can be processed further. OB86 prevents that the system enters run-stop mode in the event of a periphery device will fault or return from fault. So this concludes our video on the CAN bus at the decentralized periphery of the INSEVIS. I hope you enjoyed the video and were able to take away 1 or 2 pieces of information. See you next time at the INSEVIS video tutorials.